Alright, this is the review for the Chapter 3 quiz. So hopefully you are in a position to attempt this. And, or skip ahead, jump ahead throughout the video to see final answers or certain explanations. But you should always try this first before watching the video. That's, I think, the way it'll work best for your preparation, and then you could then by going over the explanations and the answers will be a little more, that feedback will be a little more useful to you. So here we go. Hopefully you've tried all these already, and what you would do first is, whoa, what a horrible start. You can't have x on both sides in order to solve for x, so we do that, and then 5x minus 3x is 2x. Bring down the minus 4, that's the left side. The right side will now just be positive 14, and now we can get the x all by itself. We first start by getting rid of that minus 4. 14 plus 4 is 18. And then we divide both sides by 2. And get 9. So again, it's get the x's only to one side, and then get that x all by itself by undoing the minus 4 and then undoing the times 2. Number 2 would probably play out like this. In order to move that minus 3x away from that side, you would kind of do the opposite. Add 3x, and of course you are adding 3x to both sides of the equation, and so the right side would now just be positive 10, but the left side we have 4x plus 3x, that's 7x. The plus 3 comes down, and now we have the x's only on one side. Now we can get everything else except the x away from that side. Starting with that plus 3, we got to get rid of that plus 3. But we still have 7x. And then over here becomes 7. And now we want to divide both sides by 7. And so x will be by itself, and the other side will be 1. Should be your final answer. Number 3. I'll do this one a couple different ways, depending on, how you like to, start these things off. I'm going to start first with my first one. I'm going to take it, I'm going to say my priority is getting the x to the left side. I don't care what the numbers are. If you want x's to always go to the left side, then you're going to be doing this. So if you want to hold off, I will be doing it the other way. But negative 2x minus 7x, that's minus 9x. Plus 3 is over here, equals, and now the right side is just minus 7. And then we would now look to get, so negative 7 minus 3 is negative 10. And now we divide. Okay, so x is going to be by itself. But what's this going to be? What's that going to be? Negative 10 divided by negative 9. That will not divide clean. And you should try to get in the habit of just leaving your answers as fractions, but they'd have to be reduced fractions. Can you reduce negative 10 over negative 9? Well, other than the two negatives, because what's a negative divided by a negative? That's going to be overall positive, right? So I'm going to do that. But other than that, I don't think this reduces at all. So it'll be 10 over 9, but it'll be positive 10 ninths. Okay? Now I'll do it here a different way. Come on. Allow me to start all over again and just play this one slightly differently. What if your priority was to keep your x term positive? If that was your priority, you'd probably want to instead add the 2x over to the other side so we get a positive 9x. That's okay. Now the left side will just be positive 3. And now we would be still looking to get x by itself. So we'd have 10 equals 9x. And now we would be dividing by positive 9. And we would get 10 ninths. I just want to rewrite this quick. 10 ninths equals x, which is obviously the same as saying x equals 10 ninths. Okay, because again, 10 over 9, that does not divide cleanly, and you should, again, not be really going with decimals so much as you're going with simplified fractions as your final answers. So either way, you get 10 over 9 as your final answer. Let's see what happens here. Looks like no matter what kind of person you are, you're probably going to do this. And the right side, what's negative 2x plus 6x? That's 4x. And what remains on the right side is a minus 4. And so now, of course, we minus 8 from both sides so that we can start getting x all by itself. Negative 4 minus 8 is negative 12, and now we divide both sides by 4 to finish getting x alone. And negative 12 divided by 4 should be negative 3 is your final answer there. Number 5, well, if you have a bubble to clear, that's probably the first thing you're going to do. You're going to multiply the 2 to the x and the 7. 2 times x is 2x. 2 times positive 7 is positive 14. The right side is x plus 19 still, of course. And now we find the need to get the x's only on one side. So we move that out of there. And what's 2x minus x? That's 1x, or just x. Still a plus 14 over there, and the right side is now just a positive 19. And now, of course, we want to get x alone. Like, remember, the end goal is to get x all alone so that we can have our final answer. And then, so at the end of the day, the right side is 5. 19 minus 14 is 5. Number 6. What's the first thing we should do here? There's no bubbles to clear, but I do see like terms already on the same side. So those would just combine to be 9x. Okay. And now it looks like we need to can't have x's on both sides, so let's move that out of there. And 9x minus 3x. See, again, like I hope I don't need to say this like ever, but when you minus 3x to the left side, you're not minusing 3x from the minus 2. You're minusing it from the 9x. 9x minus 3x is 6x. The minus 2 is just another term over there. And the other side is now 16. Keep on cruising. And so when we finally have x alone, it's x equals 3. The other side's 3. Number 7. This is the kind of example where, especially if the fractions are like 28 and a fourth, 91 and 1/4, or like 1/2 x, just change them very quickly to like very clean, very neat and tidy, you know, nice, very nice decimals. So before I do anything like real, why don't we just take a moment to rewrite 28 and a fourth to just 28.25. In this case, I know I sound like a big hypocrite right now, but in this case it might be better to change these to decimals. Okay? Like when we get to the final answer, see, the final answer is the final answer. We'll get to the final answer and deal with that then, you know what I mean? Because like I said a few moments ago, the final answer, you should start to really lean more towards having it as a fraction instead of a decimal, but I know we'll cross that bridge eventually here. And so 1/2 is like 0.5x, and the other side we could just say is 91.25. And now we have we have like terms right here, which would be like 1.5x. This term just comes on down, equals 91.25, and now we look to so 1.5x equals, okay, what is this? What do we have here? 91. Let's just make certain on a calculator. 91.25 minus 28.25. 63. Okay, and now we're going to finish getting x by itself. Dividing by 1.5, and we get 42. So the final answer ended up being a very clean 42, not 42.25 or whatever. So no worries, you know, like really all that matters is the final answer, and it's just nice and clean, whole number, 42. Number 8, here we go. We have the classic dimes and quarters problem, where we are going to use a variable q for the unknown number of quarters, and we're going to use the variable d for number of dimes, right? So we have d and q for number of dimes and quarters, and if there are 6 more dimes than quarters, so there's more dimes than quarters, right? So 6 more dimes. So that would mean, like, if you take the number of quarters, you could just pretty much say that, well, maybe we'll call that Q. Again, like, you don't want to get this wrong, right? So if there's 6 more dimes, wouldn't that mean that the number of dimes would be whatever the quarters are plus 6, right? So Q we're just going to call Q, and D we're going to call Q plus 6, because there's more dimes, which means, like, if you do Q plus 6, that'll be the same as D. So now we can kind of do the 445 thing, where it's like 0.10 times D, and I might need to lower this a little bit, plus 0.25 times Q, right? If you multiply 10 cents times the number of dimes, and you add, and you're going to get how much money in dimes. And if you multiply 0.25 times the number of quarters, you're going to get the amount of money in quarters. And when we add all this up, we're supposed to get $4.45. But again, we can't really, it can't remain two different variables. That's why we have this. And so instead of a d variable, we're going to replace that with q plus 6. And that way, we will only have the letter q, and we can actually solve it for q, because now there's only one letter at a time. So we distribute. 0.10 times q is 0.10q. 0.10 times 6 is 0.6. And I see a couple of like terms, which combine to be 0.35q. And now we can just finish off getting q all by itself. So let me come up. Maybe there will be space up here, hopefully. So we have 0.35q equals, let's make sure, let's not take any risks here. 4.45 minus 0.6 is 385. And now we would, of course, divide both sides by 35. 0.35. And it looks like q equals 11. So we needed to find the number of dimes and quarters. Well, q equals 11, so that's 11 quarters. And if there's 11 quarters, there's 6 more dimes. So that would be then, if there's 6 more, $17 dimes. And you could double check that answer as in, okay, so there's 6 more dimes, but do 17 dimes and 11 quarters make $4.45? And they should. 9, 10, and 11, this is about just knowing that if you get x equal to just some number, that means there's only one solution. That's the normal case. This is what happens like over 99% of the time in high school. But if not, if all you end up with is like a false statement, that's 0 solutions or no solutions. Either answer is acceptable. But if we end up with just kind of a blanket true statement, that means there's infinite solutions. So you just have to know those particular exact questions. And now here, the directions talk about, work this equation and make sure to, answer with how many solutions there are. Tell whether there's one solution, no solution, or an infinite number of solutions. Okay, and so here we would start by distributing. And getting 6x plus 42 on the left. And then when we move that x up, it looks like the x's canceled out on both sides, and what we're left with is just a statement that is either true or it's false. Does 42 actually equal 7? It does not. That is false. So the final answer is that there is no solution when there's a false statement. Number 13, looks like we have to start by clearing the bubbles. By distributing. And now we move that. to the other side, and so that's 3x. Okay. Add 10 to both sides. So 3x would equal 12. And when we divide both sides by 3, we get x equals 4. So we get an answer, x equals 4. And so that means that there is one solution, which happened to be x equals 4. In this problem, it looks like there's some like terms that are already on the same side. So we get to there, and now well, looks like it's going to cancel out on both sides, and we're just going to be left with 4 equals 4, which is just flat out true. And what does that mean? That means there is an infinite number of solutions. Number 15, it looks like there's a couple like terms already on the left side together, which make 7x. When you combine them, and now we have to get the x's only on one side, but it looks like when we do that, the x variable totally goes away, and what we're left with on the left is 8, and on the right we have 12, so 8 equals 12. That is just flat out false. 8 does not equal 12. Liar. And so what that ultimately means is that there is no solution to this problem. And that is everything you would need to know, all those kinds of problems, in order to do well on the quiz for Unit 3.